Haley, if you want to try it again, that drawing the diagram. Someone took down the picture.
Good. What picture? I want to see that. It's on the ground.
Yo, where'd you get the video?
All right, have a seat. All right, now we're live. Here we go. So, by corresponding angles postulate, we can say that 2 and 4 are congruent by vertical angles, and 2 and 6 are congruent by corresponding angles, which means 4 and 6 are the same. That was alternate interior angles theorem. We proved it yesterday. We also did same side interior angles. An example of same side would be like 4 and 5, right? And we proved they're supplementary. The way we did that is we said, look, 4 and 3 are supplementary, right? Oh, let's do this. Let's do 4 and 1. 4 and 1 are supplementary. And I know 1 and 5 are the same by corresponding angles, right? So if 4 and 1 are supplementary, then 4 and 5 are supplementary, because 5 is the same thing as 1. Now today what we need to do is do the external angles. That was what you were assigned to do. Yeah. So, Rosie, give me an example of two. You want to do alternate or same side first? Wonderful. That was what you said yesterday. Alternate exterior angles. Give me an example of alternate exterior.
7-1.
Wow. Great. Dykema, shut it. Also, put away the phone. We've realized you can't handle it. It doesn't work. Other people can, but like it's not working for you, bud. We're almost in quarter 2. I gave you all quarter 1 to figure it out. You haven't. Sorry. I'm not saying I'm going to make you put it away. I'm just saying you really should. You really should. All right. So 1 and 7. We're going to prove that they're congruent. That's our goal, right? Now, will they be congruent? Let's double check, right? I know 1 and 2 are a linear pair. That means they're supplementary, right? Isn't 2 the same thing as 7? So they should be supplementary, right? Say nothing. Is 2 not the same as 7? Oh, I thought they were corresponding. No, 2 and 6 are corresponding, aren't they? Yep, right? 2 and 6 are corresponding. Remember, corresponding angles mean that they're in the same relative location, meaning that if you look at the intersection here, top right corner is 2. Look at the section down here. Top right corner is 6. They're corresponding. Not 2 and 7. 7's in the bottom right corner. So 1 is supplementary to 2, which 2 is the same as 6. Fine, whatever. We don't care about that. 1 and 3 are the same by vertical angles, aren't they? Okay. And 3 and 7 are the same by what? Cap, corresponding angles postulate, right? Therefore, 1 and 7. So yeah, they are going to be congruent, and that was literally the proof. So now let's write it. So angle 1 is congruent to angle 3. That's one way to do it. How do we know that angle 1 and angle 3 are the same? Vertical angles theorem. Remember, it's the scissor theorem? Your words, not mine. Angle 1 and angle 3 are the same because they scissor each other, right? So we have vertical angles theorem as another thing we can use to prove stuff. Disgusting! Well, it was one of yous. 1 and 3 are congruent by vertical angles theorem. Haley, same thing for you. For Dykema goes for you. Wilson. All right, so here we are. 1 and 3 are congruent by vertical angles theorem. Great. Well, we want to know something about angle 7. We have no statements about 7. How do we? What's the relationship between 3 and 7? What's the relationship between 3 and 7? Brainerd? Same goes for you. Put it away. 3 and 7. How are they related? Someone help them out.
Same side something.
Yeah, that's not what we're looking for. Corresponding, because they're both in the bottom right corner. Okay? So angle 3 is congruent to angle 7 by cap. Okay, so now what does this mean? Well, check it out. 3 is the same thing as 7. So whenever I see a 3, I can replace it with a 7. And that's what we want, right? So our last step is going to be to substitute. Instead of writing angle 1 is congruent to angle 3, I'm going to write angle 1 is congruent to, instead of writing 3, I'm going to replace it with a 7. By subs. Again, what does congruency mean? It means they're the same dumb crap. 3 is 7. They're the same dumb thing. So they're interchangeable. So instead of writing 1 and 3, which isn't what I want, I can write it as 1 and 7 by substitution. Swag box. It's all right. We all make our own choices. All right. So, done?
No.
Done. That's it. We did. 1 and 7 are congruent, right? So what we did is we proved that, look, alternate exterior angles are always going to be congruent if these guys are parallel. So I forgot one step. My bad. I forgot to write the given, didn't I? given that L is parallel to M. Right? As long as those lines are parallel, that's going to be a true statement. If they're not parallel, it's not going to happen. Right? We're going to have a mess over here. My final answer? That's the answer. It's the proof. It's the whole thing. To angle 7. Yeah, the thing we wanted to prove, right? Smell what I'm stepping in? Yeah. That's all good. It's all good. You did a nice job on your quiz.
No, I did.
Yeah, you did.
My quiz? I got 54.
No, you didn't.
Hey, Mac, I'm missing quiz 3.
What are you talking about?
I'll show you later. You graded yourself way too harshly.
Really?
Really?
I was stressing
Really?
myself.
Really? That is the classic Schlaffer phrase right there. Really? Yeah, you can if you want.
Hell yeah.
All right, so here we go. We've done alternate exterior angles. Now we're going to do same side exterior. So give me an example of same side exterior angers. How about you, Keaton? Same side exterior angles. They're on the exterior. They're on the same side.
Oh,
1 and 8. I always get frustrated because I'm like, I want to do one that we haven't done yet. And then I'm like, oh, I'll go to the 2. And then, oh no.
Oh, no.
There's always an overlap. All right, so 1 and 8, yeah. Are they going to be supplementary or congruent? What do you think? 1 and 8. 1 and 8. Supplementary, she says. Let's see if we can back that up. Well, 1 and 4 are supplementary because they're a what? Linear pair, right? They're not vertical. They're not crisscross applesauce. Linear pair. So they're supplementary. Now, notice 4 and 8. Why do we know they're the same angle? Corresponding, right? So if 1 and 4 are supplementary and 4 is the same thing as 8, then I can say instead of 1 and 4 are supplementary, I can say 1 and 8 are supplementary. There's the proof. Done. So 1 and 8 are going to be supplementary. No yawning in math class.
what would you write down for that?
So here's what we're going to do.
Function, I can't help it.
Our goal is to prove that angle 1 is supplementary to angle 8. That's our goal. Angle 1 and 8 supplementary. Not congruent, but supplementary. So, first off, given that the lines are parallel, because if the lines aren't parallel, that won't be true.
Can I try this?
Yeah.
Okay.
So what do you know about angle 1?
That it's corresponding with angle 5.
Ooh, she's doing it a different way than I did. She's thinking for herself. Well done. So angle 1 is corresponding with angle 5. So we're going to use cap. So what does that tell you about angle 1 and angle 5?
The same.
They're the same. They're congruent. 1 is the same thing as 5 by corresponding angles postulate, right?
Yeah, and then 4 and 8 are the same, right?
They are. That's true.
So,
You're doing it in a more convoluted way.
I'm making it too complicated.
You are.
Like, I'm translating.
So what's going to happen? No, it's fine. It's fine. You're saying 1 and 5 are the same, 4 and 8 are the same,
Yes.
right?
And because 1 and 4 are supplementary, so are 5.
Mm-hmm. There's a way to do that. What you'd have to do is show that they both equal 180, set them equal to each other, then substitute stuff out, subtract stuff, and then you'd get 1 and 8 are equal to each
So
other.
I can do words, I can't do math.
Right. So I'm going to show you a better way of doing this, a more efficient way, okay? Because the words are good for the most part. We just need to get this written in math form, okay? So 1 and 5 are congruent. That's great. Now, what do I know about 5 and 8? Because if I can create a relationship between 5 and 8, I can switch them out, right?
They're supplementary.
Okay. So 5 and 8 are supplementary. And 8 are supplementary. And we know that by what? How do we know 5 and 8 are supplementary? We've got 3 things we can use. Linear pair theorem, vertical angles theorem, and cap. Linear pair, right? They're a linear pair. They're on the same line. There's 2 of them. Exactly 2.
Wow.
So by LPT, they're supplementary. So if I know 5 and 8 are supplementary, and I know that 1 is the same thing as 5, can I switch them out?
Yes.
So I'm going to switch out 1 for 5, and that's going to get us 1 and 8 are supplementary. That's the fast way of doing it. You did a great job, though. Because you were absent, right? You didn't take it. Now we substituted to get there. Swag box. Thomas.
It really, the question doesn't make sense, but it's like, for like instead of using LPT, somewhere in my mind says that you can use angle addition postulate since they are angles and adding them. But no.
Nope. So angle addition postulate says the 2 small angles add up to the big one. So look at 5 and 8.
Yeah.
They would add up to the big angle, the green angle. Okay? I don't have a name for that angle. You want to call it angle 9? Right? So we could write something like angle 5, the measure of it, plus the measure of angle 8 adds up to 9, which could be useful, right? But it's not going to get you the thing you want. You want to show that they're supplementary. That's by linear pair theorem. Linear pair theorem says if they're a linear pair, which they is, then they have to be supplementary. So there it is. Okay? But I understand the confusion because it's like adding them up, right? You feel a little bit better about these proofs?
I'm slowly.
A little bit? Yeah, that's okay. Time is the number one factor in your education. We've talked about this. All right, put that away. Get out, please. This thing. I know it's not due yet. It's all good. Wonderful. Yes, ma'am. You were gone. Stop doing that. Yeah? Yes.
Violently ill. I'm dying. I got better.
All right, pro tip. You don't have to keep your phone under the table if it's out in here because like you're going to make your own life choices and I'm not going to make you like do things. But I will highly suggest, especially those of you that owe me quizzes because you bombed them, that your strategy ain't working, so try a new one, right? If you can't be adult enough to be like, I'm going to put my phone away because like that's like rude or whatever, because like I don't give a crap about that. Let's be honest. I really don't. You don't have to respect me, right? I don't care. Like all I ever wanted for high school is to respect me. Like I could care less. But if you can't be that adult, then be adult enough to know like what I'm doing is not working for me because I just am not capable of handling both, right? Like that's all I'm saying. I'm not gonna get mad at you if you don't. Yeah, it's just a suggestion. Like I don't know, care about your grade or don't. Doesn't bother me. It's not mine. And I'm not saying that in a mean way. I just mean it like sincerely. Like I don't care if you don't care. All right. Given that AFB, the angle, and EFD, the angle, equal 50. So they equal each other and they equal 50. That's this angle here. That's that angle there. We should probably write that down. 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 They also tell us that points BF and D. BF and D. You know what that stands for. And then EF and C, Eric's Fried Chicken, are collinear. So BFD and EFC are lines. That's all they're saying. That's good because we don't have to guess. Notice that AFD ain't a line. And it's very easy to tell because it's got a bend in it. Okay? And that's fine. That doesn't make you any less of a man. BFD here is a straight line. It looks like it, but maybe it's bent a little bit. I don't know, right? It's kind of hard to tell, right? If I look at it this way, it's like sort of bent, but like, you know, otherwise it looks straight. So I don't know. But if they tell you it is, then you're good, right? BFD is straight line. EFC is a straight line. Wonderful. That's all that means. State whether each pair of angles, the ones given here, are vertical, a linear pair, or neither. Then tell the angle measure for each. Well, we already got two of the angle measures down. BFC, Brian's Fried Chicken. Let's do that in orange. Orange. And then DFE. Already done here in pink. Somebody tell me the relationship between the pink and the orange. They're vertical, baby. That's scissors theorem all day. I will accept the scissors. You can tell me that. Your word's not mine. Whoops. Vertical theorem. Sorry. Vertical angles. Angles is spelled with an L-E-S, not E-L-S. We're not talking about angels, okay? We're talking about angles. Not that there's anything wrong with that. Again, scissor theorem. Top and bottom are the same. One of these days I'm just going to start bleeding out in here. I'm just going to be like, that's it. This is how I go. It's my time. BFA. BFA. That's a Bachelor of Fine Arts. That's for the people that couldn't handle a real music degree. BFA and DFE. These two angles are congruent, but that's a coincidence. They are not a vertical angle pair, are they? No. Are they vertical angles? No way. That's not scissor theorem. One's going to the side, one's going up and down. Are they a linear pair? No, because linear pair says two angles on a line. How many angles we got here on one line? Three, more than two. That's the perfect answer, which means it's wrong. They're not a linear pair. They're neither. Neither. Now, we learned earlier that this is 50 from vertical angles, right? So we should probably write that down. Write that down, write that down, write that down. Yeah. All right. BFC and CFD. So we're talking about these two. I will take the liberty of making CFD blue. What do we know about the blue and the orange angles? The blue and the orange. Are they vertical angles? No. One's on the left top, one's on the right side. That ain't vertical. What are they? A linear pair, thank you. They're two angles that make up a line. Yay! So what does that mean? Linear pair theorem says if they're a linear pair, they have to be what? Supplementary, which means this guy has to be 130. Cool. So we call those a linear pair. Remember, this is an example of collinear angles. Right? They're all collinear. But the magic doesn't happen unless there's only just two of them. Linear pair. Right? AFE. AFE. That's this angle right here. I'm going to do that one in Korean. AFE. Okay? And then we've also got the angle, what do they call it? AFC? Like the football thing? Yeah, it is. Okay, so AFC is the purple angle. He's a big guy. Nothing wrong with that. All right, so we got green and purple. What's the relationship? Are they vertical angles? No. Are they a linear pair? They are. You're like, but wait, there's three angles. No. That's one angle, and there's the other, and they make up together a line. Do you see how this purple angle right here would exist even if that line wasn't there? Like if I got rid of that line with B on it, see how that's one angle? So that's one angle plus another angle, makes up a whole line. Okay? It's irrelevant that there's a line in the middle. Before it didn't work because we had a gap, right? We had an angle here in pink, and we had an angle here in pink, and there was a gap in between that didn't include it, right? So all of the purple and all of the green, together they make up a linear pair. Which means by linear pair theorem, they must sum to what? 180, right? They're supplementary. So by angle addition postulate, Mr. Schlaffer, by angle addition postulate, the two smaller angles should add up to the big angle. So what's the big angle going to be? Hundo, which is what we're keeping it. And now by linear pair theorem, those two should add up to 180, which means this guy is 80. Like my grandma. The rest are on your own. Turn the page. Transversal. Sounds like a wrestling move, but it ain't. Somebody tell me their own definition of a transversal. It's a what?
A line that goes through parallel lines.
Doesn't have to go through parallel, actually.
No.
It just has to go through two others. The magic happens when those happen to be parallel, though. That's when all the other theorems are true, right? Like cap and all that, right? But it doesn't have to be. We can have two lines that aren't parallel like that, and then we can have a line like that being a transversal that cuts them both. It's not as pretty and it's not as useful, but we still call that a transversal. I wish they would just be like, yeah, it has to be parallel. That'd be so much nicer, but they don't. It's a line that cuts two others. So in our diagram, what figure here, angle, line, whatever, what is an example of a transversal here? T, line T. You can write it like this. I hate writing lines like that. Or you can just do a cursive T, because cursive lowercase letters are almost always lines. Corresponding angles are congruent when the lines are parallel. What are corresponding angles? Well, they're angles that what? Are in the same relative spot, same relative position. Remember, it's not the exact same position, otherwise they'd be on top of each other, inside each other, kind of like that monster abomination we saw on Friday. Snitches get stitches, by the way. I got kids coming in here saying, hey, let's see it. I'm not showing them any movies. Angles that are in the same relative position. What do I mean by relative? Here's what I mean by relative. Okay? Angle 1 and angle 5, are they in the exact same spot? No, otherwise they'd be both called angle 1. But if you look at their intersections, see how they're both in the same relative spot? From this intersection, we have the top left. This intersection, he's the top left. So they're in the same relative spot. So angle 1 and angle 5 are examples of that. Do the rest on your own. Thomas.
For corresponding angles, do they have to be on the same side of the transversal?
They always will be on the same side, won't they? Mm-hmm. Ah. It's like the baby with the peanut butter. I love that. Tell which angles are congruent. List all of them. Do that. Tell which angles are supplementary. What does supplementary mean? They add up to 180. A lot of you guys screwed that up in the last quiz. You said things were adding up to 180. And they said complementary. Reading is hard. Math is easy. List which ones are supplementary. Do that. Now it's the time of the day where I call you by name and you tell me either school is for fools or you walk on up here and see your grade, okay?
I already know my grade.
Wonderful. So your answer will be school is for fools to save me time. What movie am I referencing? School is for fools.
I don't.
Airplane.
Mad. Stop looking at me, Swan.
My shoes tied.
Yep.
Did you say Miss Swan?
No, I said stop looking at me, Swan.
Because isn't Miss Swan the lady in the Cabinet Hat movie that hangs in the closet? I think her name's Miss Swan. That hangs in the
Yikes.
closet. No cheating.
Justice.
School for fools.
All right, Kayla Carpenter.
Cool.
What?
Yeah. Okay. Sydney Cook. Nice. Dykema.
School for fools.
Tana.
No, if we want to.
I was like, give me a minute.
All right. So